Okay, so here we're going to do levels of measurement practice after watching the video we just did. The teacher of a class of third graders records the height of each student. Okay, this would be ratio because we could say that zero height would mean it would be the starting point, and a student that is 6 feet tall would be twice as tall as a student that would be, let's say, 3 feet. I know that's probably not a good example, but that would be ratio. Okay, the next one, the teacher of a class of third graders records the eye color of each student. Well, this is going to be nominal because eye color is not a number. And remember, nominal, okay, nominal means name only, okay, and it is also the lowest level of measurement that we use. Remember, we have nominal, and then we have interval, ordinal, I skipped, then interval, and then ratio. Okay, then we have the teacher of a class of third graders records the letter grade for mathematics for each student. Okay, a letter grade. So this would be, you can order these grades with A as the highest, right, and F as the lowest, but you can't take differences here. So you can't add or subtract or doing a calculation like that. An A and a B grade could be separated by just like a few points, or it could be several points, and there's not any way to tell if we're just given a list of letter grades. So because of that, it would be ordinal. Okay, let's look at the next one. The teacher of a class of third graders records the percentage that each student got correct on the last science test. Well, this is going to be ratio. Okay. The numbers have a range here from 0% to 100%, and it makes sense to say that one score is a multiple of another score. In other words, if someone made 50% and someone made 100%, well, the 100% student scored twice as good or twice as better as the student that scored a 50%. Okay, the next one. A meteorologist compiles a list of temperatures in degrees Celsius for the month of May. Okay? This is the interval level. Okay, remember we talked about temperatures. They can be ordered. We can put them in order. And then we can also add and subtract. We can look at differences. So this is, first of all, we could say this is quantitative data. However, think about a 10-degree day. The statement, a 10-degree day is half as hot as a 0-degree day. That's not correct. Okay, so this is not ratio, which means it has to be interval. We can add and subtract temperatures. There's no 0 point as the starting point. All right, let's look at the next one. A meteorologist compiles a list of temperatures in degrees Fahrenheit for the month of May. Okay, so we're still doing temperatures, So this is going to be interval for the same reasons as the problem above. Remember, interval and ratio are quantitative data. Nominal and ordinal are qualitative. All right, let's look at this one. A meteorologist compiles a list of temperatures in degrees Kelvin for the month of May. Be careful here. Even though this does involve temperature, this is actually a ratio. And let me explain why. Okay. The reason why this one, Kelvin scale, has an absolute 0, the reason why is because it has the absolute 0 point. Okay. It has a absolute 0 point and it goes up from there. The 0 for Fahrenheit and Celsius, though, it's not the same, okay, because for Fahrenheit and Celsius you can actually have negative temperatures. All right, let's look at the next one about, and I think we have a few more after this. A film critic, so I'm going to put the answer down here. A film critic lists the top 50 great movies of all time. Okay, so this is going to be ordinal. Okay, the rankings can be ordered from 1 to 50, but you can't compare the difference in rankings. It's kind of like the top 10 cities example. Movie number 1 could beat movie number 2 by a little bit or by a lot. There's not really any way to tell. All right, number 9. A car lists the most expensive cars for 2012. Okay. All right, this is going to be also, this is going to be prices. And technically it would depend on how this was listed, but let's say it lists the most expensive cars and their prices, and we're going by the prices. If we're going by the prices, it would be ratio. If we were ranking the cars from top 10 expensive cars from 1 to 10, then it would be ordinal. All right, let's look at the next one. The roster of a basketball team lists the jersey numbers for each of the players. All right, and we kind of talked about this one before, about the numbers, okay? Even though we do have numbers associated with this, the numbers are just an alternate form for their names, okay? The numbers identify basically who the player is, and since it's just a name, it's going to be nominal. And then a local animal shelter keeps track of the breeds of dogs that come in. This is just names, so this is also nominal. Okay, now if we keep track of the weights of dogs, that would be different. Okay, because this is going to be like height and length. It would be ratio. Okay, 0 pounds is going to be your starting point for all weights. And it also makes sense that you could say a 5-pound dog is a quarter, 1/4 of the weight of a 20-pound dog. So that is why it would be ratio. So hopefully this will help you practice knowing the difference, and you'll practice it even more on the homework. So let me know if you have any questions.